You ever get that weird feeling that your phone, your computer, that it can somehow read your mind? Well, there's a super powerful force making that happen, and it's called machine learning. Today, we're going to pull back the curtain and see exactly how it works.
Okay, think about YouTube. You know when you're deep in a rabbit hole at 2 a.m., you watch one video, and boom, the next one in the queue is exactly what you wanted to see next. It's almost creepy, right? How in the world does it know you so well? And then there's your email. Just imagine the absolute tidal wave of junk mail that's trying to get into your inbox every single day. And yet, somehow, it stays pretty clean. It's not magic, you guys. It's just a really, really smart gatekeeper. And of course, we've got stuff that feels like it's literally from the future. I'm talking about self-driving cars. Cars that can see the world around them, process it, and react. Sometimes even faster than we can.
So how does all this stuff work? Your YouTube feed, that spam filter, the self-driving car. What's the common thread? Well, the answer to all of these is a truly game-changing technology that's completely reshaping our world.
And that technology is machine learning. Now, to really get what this is, you kind of have to throw out your old ideas about how computers work. Check this out, because this is the key. With traditional programming, we write the rules. We tell the computer, hey, if an email has this specific word, it's probably spam. We feed it rules plus data and it spits out an answer. But machine learning, it completely flips that on its head. We give the computer the data and the answers. We show it millions of emails and just say, these are spam and these are not. And then the machine figures out the rules all by itself. So what does that mean? It means these systems aren't just blindly following a set of instructions we gave them. No way. They are actually learning from experience, from data, and they get better over time without us having to reprogram every little thing. They adapt. Honestly, this is the perfect way to think about it. It really is like teaching a child. You don't give a toddler a 500-page manual on how to identify a cat, right? Of course not. You just show them a cat and say, look, kitty. They learn from seeing examples. And that, right there, is the heart of machine learning. Okay, so let's stick with this child analogy for a bit. If a machine really does learn like a kid, what does that actually look like? Well, it's basically a three-step dance. First, you just show it a ton of examples. This is the data part. Instead of telling it what a cat is, you just show it thousands of pictures of cats and dogs. Next, the machine starts to notice things on its own. It sees pointy ears, whiskers, fluffy tails. This is the training phase, where it's finding the patterns. And finally, after seeing enough examples, you can show it a picture of a cat it has never seen before, and it goes, that's a cat. That's the prediction. It's gone from just looking at pictures to actually understanding. All right, but here's the thing. Machine learning isn't just one single thing. It's more like an ice cream shop. It comes in a few different flavors, and you use a different one depending on what you're trying to do.
So flavor number one is called supervised learning. Think of this as learning with a teacher, or even better, like studying with the answer key in the back of the textbook. You give the machine a bunch of data that's already labeled. All these photos are tagged cat, all these are tagged dog. It learns by looking at the examples and the correct answers you've already given it.
A perfect example of this, predicting house prices. You feed the machine tons of data on old house sales. You know, the size, location, number of bedrooms, and what it's sold for. It learns the patterns, so when a new house goes on the market, it can make a really good prediction of what it's worth. Okay, next up is unsupervised learning. And with this one, we take away the teacher. We take away the answer key. We just dump a giant, messy pile of data in front of the machine and basically say, okay, figure it out. Find some interesting patterns in here. It's all about discovering hidden structures on its own. You see this all the time when you're shopping online. You know that customers who bought this also bought section? That is pure unsupervised learning. Nobody told the computer to group coffee maker buyers with coffee bean buyers. It just looked at millions of purchases and figured out that pattern all by itself.
And our third and final flavor is reinforcement learning. Now this one is a lot like training a puppy. It's all about trial and error. The machine tries something. If it does a good job, it gets a reward, like a digital treat. If it messes up, it gets a penalty. And over time, it just wants to get as many treats as possible.
This is exactly how an AI learns to play a video game or master something like chess. It starts out totally clueless, just making random moves. But it plays millions and millions of games, and with every win, it gets a reward. It learns which moves lead to victory. Eventually, through all that trial and error, it becomes an unstoppable grandmaster.
So we've got our three flavors of learning: supervised, unsupervised, and reinforcement. Now let's connect it all back to where we started and see how this stuff is, well, pretty much everywhere.
So let's put it all together. That YouTube algorithm that reads your mind, that's learning from your viewing habits. Your Gmail spam filter, that's learning from billions of emails to spot the junk. Self-driving cars, they're learning to recognize stop signs and pedestrians. Even in finance and healthcare, it's learning to spot fraud or help predict diseases. It's like this invisible brain working behind the scenes of our entire world.
Okay, so we've covered a lot, but if you're going to walk away with just one thing, let it be this. It all boils down to a super simple 3-part process.
At the end of the day, all machine learning really does is this. It recognizes patterns, it uses those patterns to make a prediction, and then it adapts based on whether that prediction was right or wrong. Pattern, prediction, adaptation. Over and over and over again, getting a little smarter each time. That's the secret sauce.
And that learning loop, it's getting faster and more powerful every single day. We've shifted from being programmers who write rules to being teachers who provide examples. And that leaves us with a huge, fascinating question to think about. Now that we can teach machines almost anything, what should we teach them next?